whether they want to
Yeah.
continue 2 sessions in
Yes,
that,
yes,
or
yes, yes.
they want to have a break. So that's fine.
Yes,
So, okay,
absolutely.
participants,
Should we, sir, should we give them a couple of more minutes? I see more people are joining in.
okay, sir. Okay, we will
Yeah,
start after 2 minutes. No issue.
yeah,
No issue.
yeah.
Okay, sir. Thank you. Participants, during the discussion, you can decide with today's resource person, Mr. Kapil Singh Mordia, that we want, if you wish to continue both the session in continuation, that's fine. It is your mutual consent, both the participants and the resource person. And if you want to take a break, you can take a half an hour break and then continue later on. So no issue.
Yes. And before, as we wait for more people to join, if you would not mind putting your names and what you do in a line in the chat, just so that I get a sense of what the audience is, and
Okay.
also if you could just put another line to say familiarity with artificial intelligence technologies,
Kapil, basically,
yeah,
these are the participants from all across India, and they are
okay,
not exclusively from computer science domain. Many of them
wonderful,
are from
yeah,
Sanskrit, economics, physics,
okay.
and so they are a mixed audience over here.
Oh, wonderful. Okay. So we will start with bare basics. We will keep it very simple.
Exactly.
And so that everyone can understand. And by all means, please understand, I always love interactive sessions. So you can stop me anywhere.
That's great.
All questions welcome. I would also include some use cases and make it really application oriented, so that it really benefits you, and not really talk about the technology jargon. I can do that for hours, but I would not do that today. I'll keep it very simple, and just make sure that we really are able to take away a few tangible things out of this session, and it just helps you think about how you can structure your educational delivery in a better way.
True. Right, sense. I have already requested in the very beginning to the participants that don't make it a monologue session. Rather, you make it an interactive session, so that we can interact with each other and mutually learn from each other. That is the
absolutely.
Absolutely.
Wonderfully said, Asim.
Participants, I will again request all of you that by the time you do have some understanding of AI and machine learning and its uses in teaching and research. So better if you can interact with a resource person, that will give you more understanding about that subject, about the theme basically, which are being discussed over here. So I will request you to make it an interactive session rather than keeping it in a monologue session from the resource person.
Wonderful.
Fine. So Kapil, with your kind permission, may I start the session, please?
Yes, please. Yes, please,
okay,
sir.
So participants, you can see that we have today's resource person, Mr. Kapil Singh Murdia with us basically, and Mr. Kapil is an IBM certified design thinking practitioner, and he is an AI evangelist. He has done several workshops on various topics like artificial intelligence, machine learning, AI uses, use cases, and its application and go-to-market strategy. Outside of work, Kapil likes to pursue varied interests. He is an enthusiastic networker in Delhi NCR tech and startup circle, and loves to volunteer for various activities to help build the local startup ecosystem. Mr. Kapil has also participated in various initiatives to improve education outcomes in schools and has co-authored 2 books on this topic. Mr. Kapil brings perspective learning on a rich experience of more than 10 years in consulting and technology industries. He is a first-class graduate in engineering from Walchand Institute of Technology and a Six Sigma Green Belt. So today we do have a very, I mean to say, academically rich, as well as the person who is having an hands-on experience on all these things. So he is basically a true practitioner. So I'm fortunate to have such kind of learned and experienced resource person with us, and I'm thankful to Kapil for sparing his time to interact with our audiences today. So thank you, Kapil, and with these words, I will hand over the floor to you, sir.
Thank you, Asim, sir. That was for your kind words. That was a nice introduction, and really happy to be facilitating this, and really thankful for all of you for your time. So I'll just start with a quick video to to actually get some imagination fired up. When we want to get in a learning mode, it's always good to sort of be a little bit more imaginative. So I'll just start a video, and this video is titled "The Classroom of 2030." How would a classroom of 2030 look like? It's a futuristic video, some of the stuff that you really see in the movies, but the reality is that some of this stuff might not be very far away. So and I actually have put the link as well in the chat, but let me just quickly share with sound and try and play this video, and let's see if this works.
Imagine stepping.
Can everyone hear that sound?
Yes, sir.
Okay, very good. So let me just start.
Imagine stepping into a classroom where your teacher isn't quite what you'd expect. How will education evolve by 2030? Welcome to the futuristic school setting of the next decade, where robots have taken the helm in education. These robot teachers, with their sleek designs and advanced AI, can tailor lessons to each student's learning style. Gone are the days of traditional textbooks, replaced by interactive digital notepads that make learning a dynamic, engaging experience. This is not a scene from a sci-fi movie. This could be the reality for students in less than a decade. Wake up to a world where your day at school is unlike anything we know today. Imagine a student in 2030 starting their day with a cheerful, "Good morning, Alex," from their robot teacher, programmed to adapt to each student's learning pace and personal preferences. As Alex walks into the classroom, the walls, alive with digital projections, greet him with a summary of the day's lessons, all set to unfold. In this futuristic classroom, traditional books are relics of the past. Alex pulls out his sleek, interactive digital notepad. With a few taps, he accesses today's lessons in holographic displays, submits his homework with a swipe, and instantly receives feedback. This notepad, a hub of personalized learning, allows Alex to dive deeper into topics with augmented reality simulations, making complex theories as simple as a game. The lesson with the robot teacher begins. Today it's a deep dive into environmental science. The robot, sensing Alex's keen interest in renewable energy, adjusts the lesson to include more on this topic. Interactive quizzes pop up on his digital notepad, ensuring Alex isn't just passively listening but actively engaging. When the lunch bell rings, Alex and his classmates head to a cafeteria where choices are suggested based on their nutritional preferences and dietary needs, all stored and analyzed by the school's AI system. Breaks are no longer just downtime, but are enhanced with ambient soundscapes and guided relaxation exercises, all designed to rejuvenate the mind and body. From the moment they step into the classroom to the end of the day, every student experiences a tailored and interactive learning journey. With such profound changes, what might the broader impacts be on the educational landscape? Imagine a classroom where every student receives a learning plan meticulously tailored to their unique strengths and weaknesses. In these futuristic settings, technology enables educators to craft individualized curricula that not only cater to the learning pace of each student, but also dynamically adjust based on real-time progress and feedback. This could be particularly transformative for students with special education needs, offering them unprecedented support and resources that align closely with their learning styles and requirements. Moreover, consider the broader implications of such advancements. Current challenges such as student engagement and accessibility are significantly addressed through interactive digital platforms and robotic instructors. These technologies ensure that learning is not only more engaging but also universally accessible, breaking down barriers that have traditionally hindered some students from reaching their full potential. As we embrace these innovations, the possibilities for enhancing education and fostering a love of learning are boundless.
Okay, does anyone have a comment or a question or anything you want to talk about this video, or any takeaway, any interesting takeaway from this video? No comments? Okay, well, consider this. And we would think that this is futuristic. This is not happening. This is not happening for the next 20 years. The reality is that I recently read that in Kerala, in one of the schools, they actually had a teacher who actually was a robot. So, and there's a whole body of work that's happening in universities and research institutions all over the world, where they're really thinking about how do we actually bring in the artificial intelligence, the robotics, the the whole world around predictive analytics, the data science into that, and improve the delivery outcomes. And think about this. Obviously, a futuristic school that I described in this video might not be possible in a country like ours, where where we cannot afford a lot on education, where spending unfortunately on education is constrained and limited. But there's also an opportunity that the disadvantaged sections, people who don't have access to the traditional conventional good quality education systems, can can they actually have the same level of access, the same level of quality access to the quality education that they can benefit and grow from. And then you think about, in a country like ours, there's a humongous amount of dropout rate. The people leaving the school system and the college system midway is staggering. So how do you actually make sure that the um, education delivery is uses AI, artificial intelligence, machine learning, data analytics, and just make sure that we try and solve some of these problems at scale. So those are kinds of things that I thought about. Obviously, in a country like ours, where inequalities are stark, there's always going to be a debate on how much we want to use technology, and how do we make sure that the entire strata of population benefits from the technology, and all these innovations in education and educational delivery are not limited to a select few, but are much more broad based and much more holistic. So with that thought, I want to quick kick off my session, but I just wanted to make sure that we take a futuristic view along this entire session when we think about AI and the potential it has to revolutionize and change and impact the delivery and the pedagogy and education in general. Even the teacher student interactivity, you can actually really make sure that is strengthened and that is reinforced. So before I go any further, any comments, any questions? Yep, Riton, I see your hand up. Go ahead, please.
Yes, sir. I have a one question that
Could you be a little louder, or bring your mic close to your mouth?
sir, do you think that a robot can perform all the roles that are presently played by our respective and efficient teachers? Do you
Yes.
think that it is possible for a robot to perform all the roles in all aspects?
So that's a very good question, Ritan. Thank you for asking that. So I would always say that when it comes to technology, and this is a famous quote from Microsoft's leader. They always say that technology is your co-pilot. Technology is not autopilot, right? So technology can help you improve your delivery. Technology can help you improve your educational outcomes, but technology would never replace, at least in near foreseeable future, the human side of a teacher. As a teacher, you have very strong emotional sensitivity, you have very high emotional intelligence, whereas programmable robots, which are just programmed on instructions, might not bring that emotional intelligence, might not bring that connection, might not bring that attention. That being said, technology is still an opportunity, because you can still improve educational outcomes by using technology as your friend, as your ally, as your partner. So teacher will still stay. The teacher is not going anywhere, but definitely teacher will be aided and helped by these robots or avatars and so on and so forth. So imagine a class of 60 people, and I'll cover that use case in a lot more depth as we sort of progress. But imagine a class of 60. As you would appreciate, a teacher cannot pay individual attention to all the 60 people in that class. But what teacher can do is, teacher can use a robot or a chatbot on any of these forms of technology to ensure that all of those students get that personalized touch and that engagement. So imagine a chatbot that can help student in real time whenever he's having a difficulty, with any of the problems or any of the stuff. And let's say you're teaching him physics on relativity. So any problems in relativity, so the chatbot would be able to answer some of those questions in real time. The chatbot can also help some of the weaker students, as you all of you are aware. Not all students learn at the same pace, so a chatbot can actually help a weaker student, with a lot more interactive exercises, some exercises or some lesson plans that will reinforce his or her learning. Now, that kind of individualized attention from a teacher's perspective is not possible for all the students, and that's where I believe technology can be of big help. Does that answer your question, please, Riton? Does that make sense? Yes?
Thank you, sir.
Okay, great. Thank you. So let's just get started. So what I'll do, I'll give you a brief introduction to AI, and we will sort of try and understand what is this AI all about, and then we'll look at some applications, and we hopefully, we'll also get some time to do a quick case study and just think about, some real life use cases. Okay, sounds like a plan. Just do a quick thumbs up, everyone, please. Thumbs up, real quick. Okay, fabulous. So let me just share my screen and open my presentation. So share screen. Just let me know when everyone can see my screen, please. Just say a yes on the mic so that I know you can see my screen.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, fabulous. Okay, so let's get started. So what is artificial intelligence? And before I do that, I think sir already gave my introduction, so I'll just quickly whiz past this slide. So what is artificial intelligence and why is it important to us? Let me just pause here and see, what is your understanding? Let's just have a couple of people talk about what is your understanding of artificial intelligence and why is it important for us as teachers and educators? Just real quick, couple of people can answer. And anything you know about AI and anything that comes to your mind on this one. Yes, please.
What we have learned in the last few days, that artificial intelligence is a machine which can uh, works with its own mind without programming.
Well, partially true, and I'll come to that in a minute. Okay, that's an interesting perspective. What else?
A machine that understands the situation and acts accordingly.
Great, that's interesting. Yes.
A machine which can perform the task of human intelligence.
Wonderful. Okay, so let's just see what is artificial intelligence. So what is AI? And I'll give you a very simple definition. So artificial intelligence is creation of a software that can replicate human behaviors and capabilities. So as we all are aware, human beings have a very powerful capability that they have cognitive capabilities. They can think, intelligence, they can process knowledge, they can do a whole bunch of things with information and data. So creation of software that can mimic or replicate these capabilities is nothing but artificial intelligence. So let's just see how this works. But before we do that, what are some of the key elements of artificial intelligence? So there are a few things: machine learning, anomaly detection, computer vision, natural language processing, and conversational AI. I will talk about that, all of these in a minute. But before I do that, let me just talk about what is intelligence and really how do machines learn. So before we deep dive into that, what is your understanding of so how does a human brain work? How think about your childhood, think about how you learn stuff. How does human brain work? Let's just talk about that for a minute, and then I'll sort of talk about how machine learning works. Anyone?
first of all, human mind perceives something and then store in mind and for the future reactions.
Wonderful. Great one. Yeah. So it human have an ability to perceive something. So essentially what they're doing is using one of our five senses: eyes, ears, nose, skin. We are and tongue. What we are doing is we are understanding, we are processing the world, and then that information that we are using to process becomes our data point, and from that we are able to derive some actionable insight. So input, process, and then the output. Right? We're all familiar with that? Yes?
Yes, yes.
Yes. Okay. Absolutely. So, what is intelligence? So intelligence, if I just contextualize this a bit more, so what is intelligence? Intelligence is one of these few activities. So learning, so you want to learn a new language like English or French. Planning, so you're planning for your next vacation or your next trip. Problem solving, how do you solve problems of mathematics? I saw a few people who are professors and teachers of mathematics. So essentially, intelligence is all about going step by step and trying to solve problems of mathematics. And then recognizing speech and faces. So there's a friend whom you met 5 years back, but just by being able to hear him, or by being able to see his picture or face, you will recognize that, yes, this is my friend and I know his or her name, and so on and so forth. So these are various forms of intelligence. Now, obviously, this is natural intelligence because this naturally occurs in human beings and in some animals as well, like dolphins and dogs and some of our pets. And this natural element, this is natural intelligence because these are naturally occurring abilities that are there in the brain. Now, some animals like dolphin also have this intelligence, and they can adapt and they can learn a few tricks as well, because they have this ability, as someone was saying, to process information and then accordingly be able to do a whole bunch of things. So artificial intelligence, now if I juxtapose this to artificial intelligence, and then if you think about how would an artificial intelligence system work. So artificial intelligence is something that's not natural. It's man-made and created by a man. So for example, there are flowers in the garden, and they're obviously different from artificial plastic flowers in a vase, or in your house you have artificial plastic flowers. Similarly, artificial intelligence is the ability or intelligence that's created by human beings in machines and is not found in machines naturally. Machine on its own will not be able to do anything. It is provided instructions by human beings. And this is very important concept for all of us to remember. Machine on its own will not do anything. A machine is a function of instructions and data that we provide to it. So someone did make a comment that, machine learning or artificial intelligence is when computers are able to do stuff on their own. Well, partially correct, but what happens is they are given some instructions or a sequence of instructions in advance, and then they are taught on a data which helps them perceive things, and basis that perception they are able to take a decision. So how does this all work? So artificial intelligence is a way of making our computer, robot, or a software think intelligently in a similar manner as human beings will think. In other words, artificial intelligence is adding intelligence to a computer or machine or devices like a simple robot as well. And how is this done? Artificial intelligence at a very simple level is accomplished by studying how a human brain thinks, how humans learn, decide, and work when they are trying to solve a problem, and then using results of that study as a basis of developing intelligent software and systems which can help computers think in a similar manner. So again, computers cannot think on their own. We have to develop intelligent software and system. And how does that happen? That happens by replicating, or that happens by duplicating the abilities of human beings, the human cognitive abilities. So let's just deep dive into this. Let's just see how this works. So we all use our intelligence to learn subjects, understand them, and solve different types of problems. And varying kinds of degrees of intelligence occur in different people. As students, if I think about myself as a student and I think about my respected teachers, teachers always support and teach us, helping us learn new things and become more intelligent. So how does this all happen? How does this all work? So let's try and learn this from the analogy and context of the animal world. So how do animals learn? So how do animals which are trained by human beings like dogs or even chimpanzees and monkeys and gorillas and even dolphins, how do they learn? So if we think about that for a minute, so these animals are trained to carry out various tasks using their natural abilities. So they have some natural abilities, but then they are trained to do activities that human beings can do. And how does that training look like? What is that training process? So in that training process, they become more intelligent and start taking better advantage of their natural abilities of perception. As an example, if you think about dogs, if you think about law enforcement, how law enforcement people like police and army use dogs, that happens by repetitive training. So, they become more intelligent after training, and they can help people with their sensory capabilities like power of smell. And we can see that training can actually help improve intelligence both in human beings and animals and help them do new activities. In both human beings and animals, repetitive training, repetitive practice, we've all heard of this phrase, practice makes a man and a woman perfect. So repetitive practice helps them learn more and become more and more intelligent. Computers are no different. Computers can also be trained to become more intelligent and do a whole bunch of new activities. And how does that happen? That also happens by repetitive practice, as we will see in upcoming slides. So much like animals, computers can also get better and improve with repetitive practice. And what is that repetitive practice all about? That repetitive practice is working on more and more data. That repetitive practice is working on more and more information and instructions. So let's move forward. So this is just a recap. So we saw how animals are trained for them to do repetitive activities to accomplish a certain goal, like finding food or doing different tricks. Similarly, computers, think of training a computer, or think of training a computer on an AI program or a machine learning. Like, how would you train your dog or your pet? So computers and machines can be similarly trained to execute goals by repetitively feeding more information, more data, and more instructions. So for example, when you are teaching your dog or dolphin what you're doing, you will be telling the dog or your pet or any animal that, okay, this is what you want to do. This is your goal. The goal is to go and find your food, or the goal is to jump through the hoops of fire. And then you will give it some inputs to perform that goal. So initially, when you're training the dog, you will take the dog close to the food. You will help it smell the food so that it can understand the smell. And then you will give them some instructions. You might say that, when the dog is, going to the hoop of fire, you will give it instructions how to jump and how to sort of, make sure that you don't get caught in the hoop of fire, and so on and so forth. And then finally, the dog or the dolphin will perform those actions or those tasks. So computers are no different. So you will decide, so when you're working with AI, when you're trying to train AI, what you will do is you will tell AI, okay, this is our end goal. So for example, my end goal is in a class of 60 is for AI to tell me how many of my students in that class of 60 need additional support in a topic like relativity in physics. And then you will give it AI some data and some inputs. You will say, okay, these are the marks of an assessment test that I conducted on students. These are all the marks. And for all the students who are scoring low, make sure that you flag them for me. So these are my instructions. And then I've also given it some data. And I might also give it some historical data just to make sure that AI becomes a lot more smarter. So I will say that, I would say historically, people who have done badly in relativity have done badly in this topic in physics. So maybe people who have done badly in light and waves in physics will have also done badly in relativity as well. And that has happened over the last 10 years. So you've got last 10 years historic data. And what AI is doing is when you're giving it some instructions and when you're giving it some data with time and with all the more activity and ingressing of that data, AI is becoming more and more smarter. And then it can carry out some additional actions. So for example, AI can predict that out of these 62 students, well, 5 students are not doing well at all in wave theory, 5 students are not doing well in light theory, and then 10 students total are not doing well in wave and light. So there is a chance that they might struggle with subjects which are related to this. So they might struggle with subjects like relativity. So AI can make some upfront predictions, and that means that as a teacher you have some insights to work on, with your class, and so on and so forth. So what is happening here, if you think about it, what is happening here is that you are giving AI a goal, that this is what I want you to do, and then you're giving it some raw inputs, instructions, and some data that might also include historic data to perform that goal. And then AI in turn helps computers or any device like a robot perform some of those actions. So that was long-winded. I want to pause here and see if anyone has a question or anything that was not clear. Questions, anyone? Asim sir, I'm not able to see if anyone is raising hand. If you have any questions, please facilitate, because I'm sharing my screen. If anyone has questions, please feel free. Otherwise, we'll move.
No questions, sir.
Okay, fabulous. Okay, great. So what is machine learning? So machine learning is a subset of AI. So AI has multiple flavors. There are multiple things in AI, and we'll talk about that, all of those shortly. But the machine learning is one of the most important applications or flavors, as I call it, of artificial intelligence. And indeed, machine learning is foundation for most AI solutions. So any AI solution, most of the AI solutions will have machine learning as a bedrock to enable that solution. So how does machine learning work, and how do machines learn? So machines, and if you just go back to that discussion that we had just now on how animals learn, and then how we can replicate that, or how we can actually juxtapose that with machine learning. So machines have access to a humongous amount of data. So they have an ability to process data in terabytes and trillions of words or images and so on and so forth. So along with that data, we also give machines a bunch of instructions that, okay, this is the instruction for you to be able to process the data. So to explain this, let me take an example. So for example, if you're planning a trip, let's say if you're planning a trip to Mumbai, how would you plan that out? What you will do is you will do step-by-step instructions. So you will say, okay, let me first plan my travel. How would I travel to Mumbai? So I might take a train, and then if I have to take a train, I have to make a reservation. And then how would I then what do I do next? So when I land into Mumbai, I need a hotel or an accommodation, or maybe I need to plan it to stay at my friend's place. So what happens is you plan that out. So you say, if you have to stay at a friend's place, you will actually call that friend up. Okay, I'm coming, are you okay for me? Or if you're going to a hotel, you will make a hotel reservation, and so on and so forth. So this is a sequential series of steps you're taking to perform any action. Similarly, when machines are working with data, you will give it a sequential series of steps to work on that data. So for example, if you're giving data of 60 students, you will tell machines, okay, in that 60 student, number one, identify the demographics. How many of them like gender? How many of them are male? How many of them female? What is the background? And so on and so forth. And then second step is, try and make some attributions, or try and sort of find some patterns. So for example, people who are coming from semi-rural backgrounds, or people who are coming from not so privileged sections of society, might be finding it difficult to understand or decipher concepts in English language versus their regional language or Hindi. So you will ask the machines to spot those patterns. But before you do that, what you will tell machine is, okay, first identify the gender and the demographics, and then according to those demographics, align the data. What are their marks? What is their performance? And then from there, you will ask the machine to derive some conclusions. So what you have done is you have given machine a data, you have given machine a data set, and then you have given machine a whole bunch of instructions or sequence of steps to work with. And then once you have given it a data and some instructions, machine will start applying its mind, or it will start processing the data. And together with algorithms and data, you will make a model. So what is a model? A model is essentially, as the name suggests, a model is a replication, or model is trying to replicate a event, or a human behavior, or any actual eventuality, or any actual action that happens in practice. So for example, a model for your class could be that you will say, hypothetically, you could always say that, in my class, if 10 students are not doing well in light and wave theory, the model could safely say that in general, it also happens. Having looked at data of last 10 years, I can make a model that these students will also struggle in theory of relativity. I'm just taking as an example. I mean, things could be different, and there are obviously some nuances, but essentially you are modeling the real-time behavior of your students by using the data and by processing the data in a specific sequence of steps. So you have created the model, and then from that model, once the model is there, and once the machines are able to spot some patterns, so as I said, machines will be able to spot the pattern that people from underprivileged background are unfortunately not doing so well in English, or they are struggling to understand lessons in English. So you now have some intelligence to work on as you sort of work with your class. So this is how the entire cycle of learning when it comes to machine actually works. So you start with data, you start with a series of steps or algorithms, and then you prepare a model which is essentially replicating the behaviors, and then you spot patterns, and then you develop some actionable intelligence. I really want to pause here because this has been a lot to absorb. So I really want to pause here for 2 minutes for you guys to process and for you to be able to ask questions. So I'll just quickly turn off my share screen so that I can see and we can interact a bit, because this is an important topic. And I just want to make sure that everyone has understood this. And if there are any questions, I can answer. Any questions, please? Is this conceptually making sense, or is this clear, or is this still complicated, or should I explain this again? Please, I want an honest answer.
Sir, can you repeat this explanation? We understood a bit, but once more would be better.
Helpful. No problem. Thank you so much, Bakhtiyar. I'm happy to do that. Okay. So let's take this as a simple example. So we go step by step. Let's say, and let me take another example so that it becomes a little bit easier for you. Let's say we have a railway reservation system, a ticketing system that we want to use for our train ticketing, and let's say Indian Railways want to use machine learning and AI in their ticketing system. So what would be the steps to think about? So what they would say is, first they will define a goal. They will say that we want to use machine learning to predict what will be the rail reservation or rail occupancy during the summer months. So obviously we know that in summer months, the rail reservations shoot up, the occupancy shoots up. So what they want to do is, using that data or analysis, they want to use AI for them to so that they would know that which routes or which trains or which stations would need more trains or more infrastructure. Let's start with a simple example. So what is the data they will have? So they will have data of last 10 years. So last 10 years, every summer they see a spike, and then they will try and get a little bit more granularity in the data. So I would say that I would identify 10 stations. So let's say Lucknow, Allahabad, and I'm just making this up just to explain this to you. So Lucknow, Allahabad, Varanasi, Jaipur, Bhopal, and let's say these are the 5 stations which are the busiest stations. And from there, trains which are going to Delhi are overloaded, and there is a long waiting list. So you have all of this data now, right? Now what you will do is you will feed all of this data. You will feed this data, and now what is your outcome? What is your end goal? You want AI to make a prediction. Okay, AI, tell me from what station to what station I need additional trains, or from what station to what station I need additional seats on the train. So what would happen is you will give some instructions to AI. So you will say, okay, amongst a list of 50 stations, identify the top 5 stations which have the maximum reservations, and these are all the starting stations, because we want to understand from where the trains should start. So you will give some instructions to AI. So you will say, okay, give me a list of 5 stations which are seeing the most reservations or most demand, and these should all be starting stations. And then you'll give it some more instructions. Now tell me from these starting stations where from these starting stations, where are the most trains going to? So they might be going to Delhi, they might be going to Mumbai, they might be going to Nagpur, and so on and so forth. So give me a list of 5 stations, and then give me a list of 5 stations from these stations. These are the destination stations. This is the destination. These are the top stations. So when you have that data, the next step for you for you to tell the AI is, okay, now you tell me, AI, Mr. AI, what time of the day, or what time of the day is the maximum demand? So obviously at 12 o'clock in the night, demand would petter out. Not a lot of people would want to go there. So you would actually ask AI, give me some time slots where the demand is maximum. So what you are doing is you are giving AI some instructions to understand and perceive the data. So pretty much like what you do with when you're trying to train an animal like a monkey, to find its food. You are giving some instructions to it. So go there. Likewise, you are giving some instructions to AI to perform analysis or to perceive the data as such. So once you have done this, so you've got the data, you've got a step of instructions: do this. Now if you combine this data and this instructions, you will actually have a model. Now this model actually replicates how a train reservation behavior or a train reservation actually works, because obviously during summers there's a huge demand, and you will find that Lucknow, Varanasi, and Allahabad, and I'm just making this up, but Lucknow, Varanasi, and Allahabad have the maximum demand, and the maximum train demand is for trains to go to Delhi, and then you will say the maximum demand is in the evening at 6 o'clock. So what you have done is you have created, along with the data and the instructions, when you've combined the data and the instructions, you have created a model that actually replicates that situation in real life, right? So once you have created that model, then AI can actually go into that model and try and find some patterns. So you will ask AI, okay, AI, find me some patterns. Is there a heavy rush on a weekend? And obviously AI now has understood the data. It knows what to look for. It will say, okay, yes, I can find a pattern that over the last 10 years there has been a heavy rush on a weekend, or on a Wednesday afternoon the traffic is relatively low. So now you have some very actionable predictive insights or intelligence that you can use in different ways. So you can use that to run special trains, you can use that to run summer special trains, and so on and so forth. So this is how the entire cycle from data to algorithm. Algorithm is nothing but sequence of steps. From algorithm to a model, that you are replicating the environment in true world, and then from model to patterns and insights, which is intelligence. This is how this entire cycle works. Does this make sense, Bakhtiar? I'm happy, by the way, I'm happy to explain again if this is not making sense. Does this make sense, everyone?
Yes, yes, this is much better.
Yes, sir. Yes, sir.
Great. Thank you. That's helpful. Yes. So any questions or anything, anyone has a question, comment, anything that didn't make sense?
So it means that in order to make a powerful AI, we have a good database so that AI can analyze and react in particular way.
Absolutely. Absolutely. In computer, if any of, I'm sure many of you are from the computer science background and some of you are not, but many of you would have heard this term, GIGO, garbage in, garbage out. So the better quality data you have, the better volume of data you will have, the better insights you will have. So data is very important. The better quality of data would have definitely lead to better insights. So yes, absolutely, Sanjeev, that's a very good point. Data is critical to good analysis. Any other question? Okay, I will share my screen one more time.
So what we understood is basically it all starts from the data,
Absolutely.
not from the intelligence point. So intelligence comes in the end.
Yeah, absolutely. Absolutely. Good data and right instructions or algorithms would create a strong model, and a strong model would definitely lead to good intelligence. And, as a teacher, this is something very important for all of us to reflect. If our data is bad, the intelligence will not come out as sharp as we want. And in an application or a use case like education, it's absolutely important, because I'll talk about the ethical dimensions of using AI in education, and that's an important topic. But if our data is bad, if our data brings those biases which are prevalent in our society and which should not be there, that would you will end up with wrong analysis, and that would not be the right thing to do, especially in an education sort of a world. Okay, let me move forward. So so we talked about this. Let me. Okay, so I'll take a simple example just to explain this and elaborate this concept a little bit better. So how do machines learn? So in practice, how does it work? So machine learning has some steps. So for example, this is an example of a machine learning technology called computer vision, wherein you input images and machines are able to identify the right species of flower. So you see, you've got 3 or 4 species of flowers. You've got rose, you've got tulips, you've got sunflower. So essentially, when you're training machines, what you're doing is you are running a whole bunch of images in front of the machine. So you will put 50 images of rose, you will put 50 images of sunflower, you will put 50 images of tulip. And then what you're doing is, along with those images, you are also putting in labels. You are labeling them. So when you put 50 images of rose, you will say, okay, computer, this is a red rose. Okay, computer, this is a yellow colored rose. Okay, computer, this is a tulip. Okay, computer, this is a sunflower. So what you're doing is, when you're putting in the images, but at the same time, you are labeling those images as well. And you are giving them a label, which in this case could be rose, tulip, or sunflower. Now, what happens? What machine is doing when it's trying to learn, it is trying to identify patterns. As I was explaining, you've got data, you've got algorithm, then it creates a model, and then in the model it tries to find some patterns. So what machine is doing here is, it is trying to find some patterns. So for example, machine will say that a flower that is in form of a bulb shape, a narrow bulb shape, is more likely to be a tulip. Now, keep in mind, in machine learning parlance, we always talk in terms of statistics and probability, and there's always a confidence level, and I'll talk about that in a minute. But so we'll say that hypothetically or theoretically, a flower that is bulb shaped and is narrow, is more likely to be a tulip, whereas a flower with a huge middle, a black colored middle and yellow flakes coming out and the outer periphery is most likely to be a sunflower. So what machine is doing as you're training it is trying to find these patterns. So bulb shape probably means tulip, a much more broader shape with a black color dotted kind of a background middle is more likely to be a sunflower. And then petals organized in a specific arrangement, this is all rose. Now when you train this with a data which is running into thousands of images, machines start getting more and more smarter, because now it's able to understand the patterns better and better. As we've discussed, with more data, it is able to understand patterns even better. So what you might want to do is you might want to throw up an outlier. So you might want to throw up a yellow colored rose, so that machine can distinguish a yellow colored rose with a sunflower. So what you will do is you will throw up a yellow colored rose and you will tell machine that look at the behavior, look at the petal structure, but there isn't a black colored middle, and still yellow, but it's a rose because it's different from how a sunflower looks like. So with all of that data, with all of those instructions to learn from that data, you are giving machines some clues, some insights, so that in future, if you give it an image, it will be able to identify that yes, this is a rose, this is a sunflower. Now, what's an application of a technology? I can give you a very simple example. Now, this is slightly controversial, but in some countries, they are using this technology called computer vision to identify delinquent vehicles on the road. So, okay, I see a car that's running at 100 miles an hour, and using the gun speed, I can actually capture the speed of the car, and then I can see that this is a black colored car, and then because the computers have been trained to identify whether it's a car or a truck, computers will be able to tell me, okay, this is a car. And then sometimes you will see a police car which has to, obviously because of emergency, it has to run fast, so it will be able to distinguish between a normal car and a police car, because you have trained it with data, and it is now able to identify patterns in that data to be able to distinguish between the right and the wrong. So as with anything else in the world, and I'm sure all of us teachers would appreciate this comment, practice makes a man perfect, or practice makes a woman perfect. So which also means that the more data you give it to the computers, the more practice they will be able to do, and with more practice they will be much more sharper in their analysis and much more likely to be correct in their analysis. The question I get always asked is, as someone was even asking, can I trust computers? Well, that's relative. Or can I trust my artificial intelligence? That's a relative question. So if it's a matter of letting artificial intelligence, pilot an aircraft, at 360, 30,000 feet with no redundancy built in, and any big error by a machine could be disastrous, maybe you would not. Yeah, but when it comes to help me understand what's the likelihood of 60 students, and out of that 60 students, what's the likelihood of these 10 students not doing well in an exam? Yes, I might want to use. What's the harm in using machine to augment my own intelligence? So that's how I think about it. Okay, let me pause here and see if anyone has a question. Anything that doesn't make sense? Anything that's not clear? Yes, please.
Sir, you said that at first we should put the data, then comes algorithms, then models, then intelligence.
Yes.
But at the first stage, the computer or AI does not have any intelligence.
That's correct. That's correct.
So how computer analyze the data without intelligence? That
yes.
It is a rose, it is a tulip.
Yes. So that's where those algorithms or instructions come into play. So we are once we have given the data to the computer, along with the data, we are giving it instructions as well. This is how you will process the data. So for example, in that teaching in the classroom example, you will tell the computer, okay, in a class of 60, you now have to pick up data as per demographics. So what are the demographics of your class? And then align the data as per those demographics. So go more granular, but you will give it those instructions. Computer on its own would not know, that I need to understand the gender, I need to understand the financial background, I need to understand the social background of my student. That all those instructions are coming from you as teacher or from the end user, so that analysis is sharper. So computer on its own will not be able to decipher and understand the data, and that's why you give it some instructions. So this is similar to how you will teach a child any subject. So a child on its own, when he or she is starting, would not know how to perceive or how to process something. But when you give it some instructions, okay, now this is 1. After 1, you have to speak 2. After 2, you have to speak 3. Once you have learned the numbers, then you have to learn multiplication. Then you have to learn addition. So you're giving it step-by-step instructions, which helps a child to learn and perceive and process the information. Computers are no more different. Think about computer think about teaching a computer like teaching your child or your student. You will, along with the data, along with the information, you also give it information. You also give it instructions to process that information, and that's very important. Make sense? Did I answer your question, Riton?
Yes, sir.
Good. Thank you. Any other questions? Anything? Any more elaborations I could make? Anything else I could add? No? Okay. Okay, let's move forward. And sorry, I should probably share my screen one more time. Okay, I'm sharing my screen. Can everyone see my screen okay? Yes, thumbs up. Okay. So let me move forward. So ethics. This is an important piece. Ethical considerations, ethics in artificial intelligence. And sorry for the typo here. This is so. If you think about how do you use AI in education, now AI has a whole variety of educational applications. So think about personalized learning platforms to promote students' learning. So for example, if I have a class of 60 students, I can give them a app, or I can have a learning management system, and every student can log on to that learning management system, create their own customized learning plan, and that learning plan will have additional videos, additional resources, additional information to support their learning. Now, that the reason it's called personalized learning system, it's because it's a two-way learning. Students are learning. When students are clicking on a link or clicking on a video, they are also learning, okay, this is an additional resource. At the same time, that learning system, because it's driven by AI, is also smart enough to understand and make some prediction. So for example, in a class of 60, if 40 students are clicking on additional topics or additional resources or additional explanations on a topic like relativity, the system would know that, well, okay, it just means that you know most people in the class are struggling to sort of work on this topic called relativity, because most students are requiring additional support on relativity. So, this is a personalized system in the sense that it is able to adapt as per students' need. And then you've got automated assessment systems, and I'm sure this is not something which is unfamiliar to you. OMRs, these optical OMRs and stuff like this have been there for a long time, where you actually use computers to do assessments. But nowadays there is also, there are also systems which can evaluate subjective materials like essays or papers and actually give some critical insights and comments as well. So again, a very powerful technology. And then facial recognition systems, and I'll talk about the ethical dimension of these in a minute. But facial recognition system to generate insights about learners' behavior. So if you have a class of, let's say, when you're working in a class of about 200 people, you might not be able to pay attention to those people. But let's say if there was a facial recognition system which would be able to prompt you that, now students, just by looking at students' faces, it is able to prompt you, okay, probably students are not able to understand what the teacher is talking about, or probably students are finding this topic very difficult. And sometimes it's very easy to understand from the faces, or for example, students are not engaged. So that's where you can use the facial recognition system. But at this moment, I want to emphasize, use that with a lot of caution. Some of these systems need to have an ethical framework so that you're using technology in the right way and for benefit of students, and not to do things that should not be done, which we'll talk about in a minute. Okay, so despite the potential benefits of AI to support students' learning experiences and teaching practices, the ethical and societal drawbacks of the systems are not considered, and that's unfortunate. And especially in an education context, it's very important that ethical challenges of AI must be identified. And that's why I'm making this effort to introduce to all of you that, what are the ethical implications, or what are some of the ethical challenges that you should be careful about when you're trying to derive AI-based systems for your education and for your pedagogy. So let's talk about these in one by one. So I want to start with a very interesting quote. This is by Stephen Hawking, which says, "Success in creating AI would be the biggest event in human history." And as we can probably all of us attest to that, AI is one of the most powerful technologies. Unfortunately, it might also be the last unless we learn how to avoid the risks. So essentially what Stephen Hawking is saying is that AI, as with any other powerful technology, is a double-edged sword, and it has lots and lots of benefits. At the same time, if we don't do things right, if we don't consider the ethical dimensions, if we don't use AI to promote equality in society, AI can be very dangerous as well. And let's just consider some of these things as well. So AI has a variety of algorithmic applications in education, such as personalized learning systems to promote students' learning, automated assessment systems, as we discussed, and facial recognition systems. Sorry, I see no noise. Can you please mute yourself? Thank you. Thank you. But despite these potential benefits, there are some ethical drawbacks as well. Let's just discuss them. So these are some of the biggest challenges of integrating these AI algorithms in education. Number one, perpetuating existing systemic biases and discrimination. So we all know that inherently any human society, be it Western civilization or any human society, would have some systemic biases, would have some inequalities, would have some discrimination. And without going into too many details into that, the challenge is that if you are not using AI in the right way, AI can actually perpetuate these systemic biases and discrimination. And I give a very famous example. Now, some years back in Germany, they found out then that they were using AI-based system to actually design a crash prevention system, or not a crash prevention system, but a crash mitigation system in cars. So every car has a seat belt, and for that seat belt, they were using an AI-based system to make sure that when an accident happens or a crash happens, the system is able to make sure that seat belts are optimized to prevent any major injury to the driver. So they designed a very intelligent system and so on and so forth. But when they run actual tests or when they run when they ran some models, or when they actually stimulated those tests in a lab, what they found out, to their horror and their surprise, was that the system was working fine for men. It worked very well. As soon as the accident or crash happened, the belt was optimized to save a man's life. But when it came to women, it just didn't work. It just failed because there was an error, or it didn't actually do the right thing. It didn't have the right sort of prevention mechanism to make sure those injuries were prevented. So when they did a root analysis, and root cause analysis, if some of you are not familiar, is a technique by which you try to get to the root cause of the problem. So when they did a root cause analysis as to why this was happening, they found out that the designers that were designing the system were all men. So there was no diversity in that team. All designers, all researchers were men. So obviously they brought their own systemic biases and discrimination, and because of that, the device malfunctioned when women were there. So very important that an AI system should be used with a lot of care. And at the end of the day, AI is just another tool in hand of people like us. So we need to make sure that people who have this powerful tool are the right people. They have the right ethical framework. They're using the right ethical frameworks, and we are doing the right things when we are working with AI, so that we are not perpetuating, or we are not making worse systemic biases and discrimination. And then likewise, on similar lines, AI should not perpetuate unfairness for students who are from disadvantaged or marginalized groups. Very important. An important component of responsible AI is inclusion and diversity, and also making sure that there is fairness when we are designing these systems. And where would that fairness come from? That fairness would come from having the right people who are designing those systems and the right data. The data should be clean. It should not inherently have those biases. And then in the similar vein, in the similar sort of a form or shape, AI should not amplify injustice or inequality. And more importantly, there's also an element of privacy and data integrity. So I take an example. So when you use a e-commerce platform or a e-commerce site, and I don't want to name them, but any e-commerce site you use, let's say you're using an e-commerce site to buy a book. So what happens? You let's say you're trying to buy a book on artificial intelligence. Automatically, when you go to that e-commerce site next time, the site would know, and it would actually make a recommendation that, okay, these are the 5 books that you would be interested in, and 4 out of those 5 books would be on AI. So how did AI know? How did that e-commerce platform knew that you were looking for a book on AI, or you were looking for a book on machine learning? Because it was using artificial intelligence to look at your browsing behavior, right? So obviously it is understanding, it is looking at your browsing. And by the way, this is just not e-commerce. This happens with your phone, this happens with your computer, this happens with any device you are engaging with. All of your interactions are being fed into these massive algorithms, and this data at a macro level is being used to glean out some insights. But with that, there comes a bit of a responsibility that you are taking informed consent. So if I'm using your browsing behavior to design any system, it is important that I inform and educate you that, listen, this is how I will be using your data. I will be capturing the number of hours you're browsing my site. I will also be looking at the pages that you're looking into, because this has privacy and data integrity considerations, and that's very important. Your data, your browsing behavior is your data. You have agency on that, and it's important that, if I'm creating a system that uses your browsing behavior for insights, I informed you, I educate you that this is how I will be using data, and these are my privacy and data integrity guidelines or stipulations, and this is how I will be using the data. Now, if you look at any of the major platforms, they make you sign up the terms of agreement or terms of engagement, and in that you will find some of this information, how they are using. And obviously they are telling you, okay, this is how we will be using your information, and please agree. And then you hit agree, and then it lets you go forward with that. So this giving information and getting an agreement from you is informed consent, and this is very important ethical pillar when designing an AI based system. Because think about it, these systems are incredibly powerful. These insights are incredibly powerful. And at the end of the day, this is completely like shadowing you. This is completely shadowing your online behavior. And if God forbid this falls in wrong hands, and as it happens sometimes, wrong people can actually misuse this data, and that would land people into trouble. So the ethical considerations and privacy and data integrity are very important, and they are very important in education as well, because when students are engaging with an app or learning management system, they're also sharing, some of the data that's private or personal, stuff like, which topics they are struggling with, how is their browsing behavior, which topic are they more interested in. So that all of that data is their browsing behavior, and it's important that we tell them how we are utilizing that data. This was an important topic, lots to process and absorb. So I want to pause here for a couple of minutes for you to absorb and answer any questions. So I'll once again stop sharing my screen. Any questions, please?
Yeah, so I just wanted to ask if this is the same policy whenever we open a website, they ask for cookies download and allowing their cookies
Yeah,
to settle in our computer. So is it the
yeah,
same?
right.
And
So
how
yes,
harmful is it
so
to assign all the cookies and allow them, give them permissions? And there are few websites
well,
we don't even open,
yeah,
when we don't agree to their cookies. So how to tackle that also? I
yes. No,
mean,
that's a very good question. So so to be honest, I don't have a great answer for you on that, because it's a trade-off. At the end of the day, it's a trade-off. Obviously, most of these, and I don't want to name anyone because I think everyone is complicit in this. Most of these big platforms make money out of your data and out of your browsing experiences. So most of them, you know, don't leave you with an option but to accept all cookies. Otherwise otherwise the functionality of that platform would not work as efficiently. So in my head, it's a trade-off, between the convenience or the functionality of that site versus parting away with your information. At the same time, there are some platforms that offer what they call an incognito mode, or work. I think there are some browsers which let you work in a incognito mode, which means that you will not be able to. I mean, most of these sites will not be able to look into your or peep into what you're doing, and so on and so forth. So there is that option, but again, at the end of the day, it's a trade-off. Most of these browsers, at the end of the day, use your data, and it's like a it's like a barter. So they use your data to sharpen their algorithms, and in return you can use some of their advanced features. So for example, there are these plugins, and there are these extensions, or there are these additional layers of functionalities that you build, like things like Grammarly, that they let build an extension on top of your browser. So there are these things, but at the same time, there is obviously a ethical dimension, there's obviously a privacy dimension. So all I'm saying is that as an end user, all I can recommend is be careful, read through what they're offering. Most of these good platforms will tell you, will be transparent. So it's just a matter of understanding that and doing that trade-off. Unfortunately, sometimes it's not completely in our control. Sometimes when you're using the incognito mode, it might not work as efficiently as generally it would work without that mode. So it's really that trade-off, and unfortunately, I don't have a good answer. But all I would say is, as a person, if I'm, and By the way, I am a startup enthusiast and I mentor startups. So I always tell startups that, be careful with some of these things. Be careful with your users' data. Be careful in making sure that you're informing people how you would use data, so that if you are ethical from day one, that's how you actually build your own brand. That's how you build credibility and trust with the brand. Because if you're not ethical, at some point in time things would catch up with you, and your customers or your users or even your students will lose that trust in you. And once you lose the trust, at the end of the day, you probably will lose your brand as well. Unfortunately, not a good answer. I can't tell you that, well, don't do that or do that, because that's a trade-off. But this is one way to think about it. Does
Yeah,
that make
that's good.
sense?
That sounds good. That's fair enough. Thank you.
No problem. That was a good question. Thank you. Any other question? Yes, please. Someone raised a hand. Yes, please go ahead. Kalpana, Dr. Kalpana Sekia, please go ahead. I can see your raised hand. I can't hear you. I think you're on mute. I can't hear you. Dr. Kalpana Sekia, I saw a raised hand. Okay, let's move forward. Asim sir, can we unmute people? It looks like everyone is muted. So can we unmute people if they have any questions? Maybe they have a question and they're not able to ask.
I think the hand is raised by mistake.
Oh, okay.
You can just move ahead. Yeah.
Okay. Thank you. Thank you so much. All right, let's move ahead. So next up, I did say that, we will talk about ethical considerations. So next, let's just move forward. Let me just start sharing one more time. Okay, so ethical challenges and risks posed by AI systems, they run counter to marketing effort that presents algorithm as objective and value neutral tools. So this is an important point. So when we think about technology, when we think about artificial intelligence, when we think about computers, we say, well, they don't have emotions, they are very objective, they are not subjective, they don't judge. How can a computer judge me? The truth is, when it comes to AI, when it comes to the results of AI algorithms, as we have discussed, the results or insights are as good or as bad as the data that goes into it. The data, if the data that goes into it is corrupt, has systemic biases, the result would also be biased and not neutral, and you will end up judging people when you should not. So it's important that we understand this nuance, and not always computers are objective, but when they are not objective, it's because they've been fed with bad data, and they're fed with data that was not objective in first place. Now, this is a very important point that I want to make today, and I want all of you to really think about this very hard. Algorithms reflect the values of their builders who hold positions of power. And I'll explain what this means in a minute. So algorithms reflect values of their builders who hold positions of power. Whenever people create algorithms, they also create a set of data that represents society's historical and systemic biases, which ultimately transform into an algorithmic bias. Even though the bias is embedded into an algorithm model with no explicit intention, you might not be intending that. It would still be there, and we can still see some biases in different AI-based platforms. So what do I mean here? At the end of the day, if you think about algorithms and if you think about AI today, most of the big products in AI are coming from big companies. And I don't want to name any company, but the familiar companies who are building big stuff in AI. Now there is generative AI and chat GPT, again, all big companies. So these big companies are strong, powerful, they have lots of money, and because they are powerful, they have an ability to drive the social narrative. And we are hearing this all this while, that today we are in a world of social media, highly polarized, and there are there are there are narratives, various narratives, and I don't want to get into one narrative versus other, but various narratives that are being driven. So essentially, these algorithms and their results reflect the values of people who are building them. And it's important to for those people, because they people are very powerful people. They have education, they are in the higher they are in that fortunate section of society who have education, have access, who know the knowledge, who know the tool, and the vast majority unfortunately does not. So those algorithms would definitely reflect those values, and that's why you will hear all big companies like Microsoft, IBM, Amazon, they all talk about ethical AI, because any product that you make out of those AI algorithms, it reflects those values. It should reflect those values of transparency, fairness, diversity and inclusion, making sure that all sections are represented, underprivileged sections also find their voice. Also make sure that you are being transparent, you are offering systems that are secure. There is a data that's, if you're playing with people's data, make sure that that's in a secure platform. So all of this constitutes a ethical framework that is very important, and as teachers it becomes all the more important as we are building these tools, because as we always say, teachers shape the future of any nation. So make sure that we are using the right data. We are not using the data that's biased, that has systemic biases. We're also making, and obviously it might be the case that as a designer or as a developer of that tool, you don't have that intention, you don't have any malified intention, yes, but even in that situation, sometimes bad data will sneak in and it will ruin the algorithm, even if you don't have that intention. So it's important that we carefully look at the data, and it's a very broad topic. How do you clean the data? How do you identify the data for any obscurities or any outliers? That's a very big topic, and that's a big discussion which is probably outside the scope of this session. But all I'm trying to say is, in principle, it's important that you apply a very robust, strong framework as you're thinking about these algorithms. Okay, with that, there's an activity we will do. But before we do that, yep, I think I've actually captured that. So, yep, let's just do an activity. So, your own personal assistant. So I will give you an activity. All of you, all you need is a piece of paper and a pen. Nothing more is needed. Just need a piece of paper and a pen. You will have 7 minutes, and what you have to do is you have to think about your own personal assistant. So let's say for your classroom session, you want to design your own personal assistant. It could be a chatbot, it could be a robot, it could be a software, it could be a learning management system, it could be anything. But all you need to think about is something, a software or a chatbot that will help you deliver your course, your pedagogy in a much more efficient way. So how do you think about it? So what you have to do is think about who your end user is. So think about your students, where are they coming from, what are some of their challenges, and then how you can use that personal assistant to solve for those challenges. So I'll give you about 7 minutes to think about this, and you can be as granular and as detailed when you're thinking. So think about your students, what are their challenges, pick up one or two challenges, try and think about how would I solve for that. So for example, if I think about the earlier challenge that I spoke about, I have about 10 students in my class who are weak students. So how might I use a chatbot to help them? So you could design a workflow. You could design a set of instructions that, okay, identify the weak students. Now for these weak students, do this, do an assessment. If assessment goes right, okay, they are good. If assessment doesn't go wrong, right, then do this. So just think about how would that workflow look like to solve that problem. And in about 5 minutes, I think 5 minutes is enough, or you need 7 minutes? Very quickly, everyone. Do you need 5 minutes or 7 minutes to think about all of this? Okay, so if no one is saying, I'll just give 5 minutes. So we are at 4:56. At 5:02, we will wrap this up. And you just need a piece of paper and a pen. Just document this. And if any of you wants to sort of do a discussion around this, you can put that in the chat as well. You can click a picture and put that in the chat, or you can type, whatever is easy. So your time starts now, and we will be doing this exercise till 5:02. Thank you. Everyone clear with what we are supposed to do? Can I just...
Can you repeat?
Yes, okay, I see a thumbs up. Yep, yes, sir. Okay, good. Okay. What I'm trying to do with this is that understand some of your challenges, and then together we can have a discussion. We can pick up one or two use cases and try and think about how we would use AI to solve for that. So I want to make it a little bit more interactive. So think about it, think about your students' problems and how you would solve them, and let's just go with that. Thank you. And I'll go on mute for 5 minutes now.
अब लैब कौन है सर? 5 सर्टिफिकेट ढूंढना है क्या?
Was that for us, sir? Someone made a comment. Was that for us or? Okay, no problem. We'll just give it 2 more minutes so that everyone can wrap up, and then we will start the discussion. Okay. Are we all good? Has everyone completed or people are wrapping up? All good? Should we just kickstart the discussion? Yes. Can I hear some yes?
Hello.
Yes, Sanjeev sir, please tell me.
Sir, एक ऐसा
Sorry, I can't hear you.
Is it okay now?
Yes, I can hear you now. Yeah.
एक इस तरह का सॉफ्टवेयर है एआई सिस्टम जिसमें मैं क्वेश्चंस और आंसर फीड कर सकूं और उनको स्क्रैम्बल कर सकूं बच्चों के लिए, जिससे कि उनका एक सेट पैटर्न ना बन सके क्वेश्चन, और एआई मेरे लिए ये काम कर सके कि उन क्वेश्चंस को चेक करके केवल मुझे बता सके कि किस स्टूडेंट के का किस तरह का प्रॉब्लम आ रहा है, उसको हम सॉल्व कर सकें। मतलब ग्रुप बन जाए कि इतने स्टूडेंट्स का इस क्वेश्चन में प्रॉब्लम है, तो उसको एक ग्रुप में डिस्कस किया जा सके। 1-to-1 की बजाय 100 की क्लास में 15-20 बच्चों के ग्रुप है कि इनको इस तरह के क्वेश्चंस में प्रॉब्लम आ रही है,
वंडरफुल,
तो ग्रुपिंग करके सॉल्व किया जा सके प्रॉब्लम्स।
ठीक है, ठीक है। सो बहुत अच्छा प्रॉब्लम आपने रखा संजीव सर। सो आई फॉर द बेनिफिट ऑफ एवरीवन can I just talk in English because I'm not as good in Hindi as I should be. Sorry about that. मैं हिंदी में थोड़ा कोशिश करूंगा बोलने का, but मैं just because I need to keep in mind that audience, not everyone in this audience. Does everyone in the audience understand Hindi? Or should I be talking in English? Just want to make sure that I'm inclusive. Okay, so we'll talk in English then, because a couple of people have mentioned they can't. Okay, so I'll keep it very simple, Sanjeev ji, for you. So Hindi, okay, English, Hindi, English. Chali, ठीक है. So I'll try and mix, and I'll try and sort of explain in a way which everyone can understand. I think 3 people have raised hands. Kalpana, Anuj. Anuj, yes, please tell me.
Yes.
बोलिए.
Yes, sir. Sir, myself, Dr. Anuj Kumar Garg. Sir, first of all, I will make a group of the 10 students of my class, and then I will tell them to log in at the chat GPT.
Right.
And then tell them to make a project on how to make a buffer solution or what are the buffer solution. And they will take a project on this title and type their problem in the chat GPT after login there. And when the chat GPT will give the all solution of this problem, then I will tell them to find the references there and to correlate it with the other sites as well, so that the authenticity of all the material could be checked, whether the chat GPT has created the desired material or not, or it is somehow the material is different from as we expecting. So we will not rely on this material. We will cross verify it from the other website as well. So
Okay, so yeah, okay. So the next session that I'm doing, and we are actually we have completed the time for this session, so that's fine. So the next session that we are doing is on generative AI and chat GPT, Anuj. So at that point in time, I will discuss what you have brought up in a much more detail, and you brought up very good point, the use cases of chat GPT, but this one is specifically focused on AI. And of course, chat GPT is also a sub function of AI, and it's a lot more granular, but I want to keep this discussion general on AI, and then we will talk about chat GPT in a little bit more depth, Anuj, as you pointed out. But thank you so much for bringing that up. Is that okay with you, Anuj?
Yes, sir. Thank you, sir. Thank you.
Okay, great. Okay, so yeah, so let's just discuss what Sanjeev sir was saying. So you have a class of 60 students, and let's say that class, Sanjeev sir, give me some more details. Let's just try and get some more details, because that's how I will give my computer some instructions. So in that class of 60 students, what is the subject, or what are the topics that you're teaching? Sanjeev sir?
Very short. Hello.
Yes,
Am I
please tell
audible?
me, please. Yes, yes, you are. Yeah.
Suppose I am talking about some orbital structure of atom.
You are Oracle instructor. Sorry, I didn't understand.
Chemistry.
Chemistry. Okay, chemistry. Okay, chemistry is a subject. And is that organic chemistry, inorganic chemistry, physical chemistry?
Like thermodynamics.
Thermodynamics. Okay, so topic is thermodynamics, chemistry. Okay. Okay. Okay, good. So the problem that we have to try and solve is that we need to create a question bank which can randomize the questions so that there is no pattern in that question, and then it actually throws up those questions to all the students in 60 people class, and then it actually makes an assessment basis the answers, and then it can tell you, okay, who are the students who are weak in thermodynamics. Is that correct, sir? Yes, is that correct?
Yeah, it's almost correct, sir. Okay. Yes.
Okay, so obviously this is I'm just trying to simplify this, and we can add more complexities and more bells and whistles as we go along. But to start with, how would I think about it? So I would say, okay, I have a class of 60 students. So what I need to first do is I need to have a question bank. And you can generate question bank in multiple ways. You can also use generative AI, as we will see in next session, to generate a question bank. So for the first step I need is a question bank on thermodynamics for class, let's say this is for class 10th. So thermodynamics class 10th, question bank of about 100 questions. Yeah, and out of those 100 questions, let's say they're all randomized as per different topics. What we can do is we feed all these 100 questions to AI, and because AI algorithms are already trained using a technology called natural language processing, they will even be able to tell you that this is most likely to be a thermodynamic question, this is most likely to be a organic chemistry question, this is most likely to be a question on physical chemistry, and so on and so forth. So let's say out of those 100 questions, AI was able to identify 40 questions that are on thermodynamics. So, and different subtopics of thermodynamics. So I don't know thermodynamics in detail, but let's say heat theory is one, and then behavior of bonds when you apply heat, and so on and so forth. So there are multiple subtopics as well that AI, because AI has already been trained using natural language processing, it's able to identify for you. So the next step is, what you will do is you will create a learning management system. Learning management system is a simple software where you will host all these questions, where you will place all these questions, and then you will have, and then what you will do is you will share link to this learning management system with your students. Now each of the students can now see those 40 questions. As we've already discussed, using AI, we have already identified that these 40 questions are from thermodynamics. These 40 questions have been randomized. They have, and you can, using AI, you can define a level of difficulty. So the student gets the easier question first and then the difficult questions. And AI today is capable of doing that because AI algorithms are already trained on that. So once you have done that, what you can do is you can have those 100 students take up those 40 questions. And obviously every student, you will share the link with them. And then what AI will be able to do, once the 100 students have taken question, you will have a data set with 100 students and then 40 questions. So on your x-axis, you will put 100 students. On your y-axis, you will put those 40 questions. And then you will be able to plot a graph that will give you the performance. Of students in those 40 questions. Now, obviously, just by seeing the graph, and graph is a better visual representation, because someone did rightly say on the chat that it's always easy to understand things by visual aids. So what would happen here is that you are using a graph. As a teacher, you will be able to see within thermodynamics, which are those subtopics on which students are struggling. That's one insight you will be able to see, because AI will do that analysis for you. So as I've explained, that cycle, AI will look at the data, AI will look at the sequence of steps. You've already given it a sequence of steps. AI will form a pattern, and then AI will give you some insights. So AI will be able to do that analysis for you in the back end, and it will be able to tell you, okay, out of those 100 students, 50 students are good with everything in thermodynamics, they are doing good. 20 students are above average, and 30 students are below average. That's one sort of analysis you will get out of AI. Simple, because you've already given it the instructions. AI has to just look at the marks. AI just has to aggregate the marks, and then AI has to divide that into divide those marks into good performers, overperformers, and underperformers. So let's say 50 people have performed satisfactorily, 30 people have underperformed, and 20 people are overachievers. So your focus of attention is those 30 people. Now you will say, hey, Mr. AI, can you tell me, out of those 30 people, which are the topics in which these 30 people are struggling, and give me topic by topic, and then you will then you will make a group of those 30 people. So okay, so in those 30 people, 5 people are struggling on, let's say, thermodynamics and bonds. 5 people are struggling, and I don't know various topics of thermodynamics, but 5 people are struggling on heat conduction. 5 people are struggling on heat convention. 5 people are struggling on equations of heat, and so on and so forth. So the AI will be able to give you that breakup. And why it will be able to give you that breakup? Again, go back to that cycle, because you have given it instructions that these are the 30 students. Out of these 30 students, these are the topics. Go by subtopic, go granular, and identify by these subtopics, where students are struggling and where students are doing well. Okay, and then eventually you will have those cohorts or clusters, and there's a technique in AI called clustering. So you will be able to cluster by topics, and then you will be able to align students through their marks, and accordingly you will be able to formulate those groups. So this is at a very high level how this works. Obviously there is a lot more detail. There is an algorithm training, there is a machine learning training that goes into it, but at a very high level, this is how this will work. Does that help, Sanjeev ji?
I understand, but I think it needs a well qualified technical person to do that.
Absolutely. So again, the idea of this is to give you a flavor of what are the opportunities that are coming with AI. This is not meant to be a coding session, or this is not meant to be a technical session, because that would take a couple of days. I mean, we can definitely make a software, but obviously I need a couple of days for you to do that. But at a very high level, I'm giving you the how to do it, what are some of the high level steps, and then you obviously there is some reading, and if you want, what I can do is I leave my email address, and I can talk about some specifics. I can talk about some specifics as to how we can do that. Okay, with that, we are at 5:20. We will take a half an hour break. We will all be assembling at 5:50, and then from 5:50 to 7 o'clock, I will be doing up a session on generative AI. It's going to be very interesting. It's latest on greatest technology in the world, and how you can use Chat GPT, how you can use prompt engineering. So I would look forward to having most of you back. And there are multiple use cases, right from building your CV, right from designing your course material, right from designing your reading plan. So everything is coming up shortly, and I will discuss some of those use cases. And it's a very practical sort of a session, really hands-on session. So hopefully all of you can join back at 5:50.
Thank you, sir. Thank you.
Great. Thank you, everyone. And I'm still around. If anyone has a question, you can put that in the chat and I will answer.
Thank you, sir.
No problem. And I'm also leaving my email address in the chat so that you can reach out if you have any further questions.